We're given a function f defined by f of x equals 12x minus x cubed, and we're asked, what is the absolute minimum value of f on the closed interval from 0 to 3? Now, whenever we're asked to find absolute minimum, we want to think of the candidates test. I'm going to write that down, candidates test. And what does that mean? Critical points and endpoints. And how do we find critical points? We have to find the derivative. My favorite. So let's do it. If we have f of x, it's defined as 12x minus x cubed. F prime of x is going to be 12 minus 3x squared, just by applying the power rule. And so we need to find when is this going to equal 0 to find our critical points. Or when is it undefined? First, I'll check if it's undefined. It's not undefined anywhere. Any x value would work, so it works fine. But let's see, 0, 12 minus 3x squared. I'm going to add 3x squared to both sides. Then I'm going to divide by 3. And then I get x equals positive or negative 2, right, when I find the square root. But do we want both of these values? Well, let's look in here. From 0 to 3 is our domain. That's the interval we're looking at. Negative 2 is not in that interval. So we're just going to say this is just x equals 2. That's the only one we care about. We don't care about negative 2. And then when we're asked to find the absolute minimum, we have to test our critical points, which in this case we only have 1, and our endpoints 0 and 3. So we want to now plug that in. I'm going to write plug critical and endpoints into original function, right? We're not plugging this into our derivative. We're now plugging this into the original function to see which one gives us our absolute minimum, our lowest value. So f of 0 is 12 times 0 minus 0 cubed. This is just going to give us 0. F of 2, 12 times 2 minus 2 cubed, which is 24 minus 8, which equals 16. And then we test f of 3. F of 3 is 12 times 3 minus 3 cubed. This is 36. Minus 3 times 3 is 9. 9 times 3 is 27. 36 minus 27 gives us 9. And so we need to see which one of these is our lowest minimum value. And I see that is, oh dear, that's not what I meant to do. Let me get my highlighter. There we go. I see that our minimum value is 0. And so our answer to this question is B.